Okay, class, so we're going to be finding domain and range for some examples here. And these mirror the problems that you'll find in the book. So let's look at one of these problems. First problem states, find the domain and range for the following coordinates. So we have 4 ordered pairs here, and we're asked to find the domain and the range. So remember, domain, it's the independent variable. So the independent variable comes as the first element in the ordered pairs. So we're going to write this in set notation. So I'm going to put a set notation bracket. And then I'm going to go through and look at my independent numbers here. The first number that is in the ordered pairs. And I'm going to list those. So I'm going to list 2, 7, 8, and 9. Now notice that I put it in sequential order. So I put the 7, 8, 9 instead of 9, 8. So you can do this as well. Now we need to find the range. So the range is the second number in the ordered pairs. And again, I'm going to write it in set notation. I'm going to write these down, 4, 11, and 13. Since the 4 is repeated, I only have to write that once. Okay, let's look at another example. So we want to find the domain and the range of this function, y is equal to x squared. Domain. So remember, with the domain we're asking what numbers can we input as an x? Well, we can put anything in as an x. We can put negative a million. We could put 2.5. It doesn't matter. There's no restrictions. So the domain here is all reals. There's no restrictions on what I can input into this function for the x. Now let's look at the range. The range does have some restrictions because depending on what I input, I get a certain output. Well, this square here means that I'll never get a certain type of number. So what do you think? What type of number never happens, or never occurs if you square something? Give me a second. I think some of you might have gotten it. That you cannot get a negative number. So the way we're going to write this is all reals greater than or equal to 0. There's no x that I could put in here that would give me a negative y. If I put in a negative 4, well, negative 4 squared gives me a positive 16. So I always get positives. So you can think of this as 0 and all positive numbers are my range. That's the possible outputs. It's not possible to get negative 2 no matter what I put in for x. Okay, let's look at another one of those. So find the domain and range of y is equal to the square root of x. Okay, let's make it square root of x plus 2. Make it a little bit more interesting. So the first thing, we look at the domain. What are the possible values that I can put in for x? Well, now I have a limiting factor of the things I can put in for x, because there's a certain rule where you can't take a square root of a negative number. So if I look at that, I'm going to say my domain is all reals greater than or equal to 0. So I can't have a number that's negative in here because that gives me a non-real number, which we'll learn later in the year. So I could put any x in that's greater than or equal to 0. And my range. Now if we look at the range, what are my possible outputs? Well, if I think of that, my possible outputs are going to be all real numbers that are greater than or equal to 2. Now, this one's a little harder to see, so let's make a little XY table here. And first x, let's say we have is negative 1. Well, we already said that that doesn't fall in the domain, so I can't have a negative 1 value in here. It wouldn't give me a y, so this one is not allowed because doesn't fall within the domain. Let's start off with the lowest number that is within the domain, 0. And if I plug in 0 into this function, square root of 0 is 0, and my y value gives me 2. Alright, well I can do that with 1. If I plug in 1 right here, square root of 1 is 1, 1 plus 2 is 3. And I can keep going, I can plug in any number. If I plug in 4 for x, I get 4 for y, so on and so forth. 16, I get 6, and it keeps going. So therefore, you can see that my range starts with 2, and it keeps going. It's all the reals from 2 to infinity. The way of writing that is you're saying all the way from 2 to infinity. And this is a different notation that you guys aren't required to write in, but I'll explain this in class as well. But this says from 2 all the way to infinity. And the open bracket means it never actually reaches infinity. The closed bracket means it does land on 2. Okay, hope this helps, and we'll have more example problems as well.